As we continue factoring trinomials, I've worked a little bit out of order. So we should have gone from factoring trinomials with the coefficient of the x squared term is 1, or x squared plus bx plus c. Then we went ahead and moved to, in this series of units that we're working with is 8-8, which is factoring by grouping. So we would have factored that first, and then the next thing we would have done would have been something along the lines of where we had 4 terms, where we would have factored by grouping the first 2 terms and the second 2 terms. And now what we're going to do is we're going to move into factoring where a is something other than 1, and we only have 3 terms, and it's going to get us into a position where we have to sort of guess and check and do some math facts and find out. We should have experimented up until now. So let's see here. If we let's just look at our first example, then we'll talk about some of the patterns that we should be seeing. So factoring a trinomial. So in this factored form, previously, if we were to factor x squared plus 3x plus 2, the only thing that we had to do, since a was 1, is we had to come up with our factors of 2, the factors of c, which added up to be b, which would be here, it would be factors of 2, which add to 3 is going to be 2 times 1. And we were simply done with our factoring there. Well, in this case, what we're going to be experiencing is sometimes, for example, right here, well, all of these examples, a is something other than 1. So we have to take some other numbers into consideration. So when we do our factoring right here, we are going to multiply our a and c values. And what we're trying to do is we are trying to split that middle term up into 2 terms because, we're going to uncombine terms. So we have 5x squared plus 11x plus 2. And so what I do is I take the value of a times c, which is going to give me a 10, and then I'm looking for what factors of 10 now, which will add to b, the middle b. So I'm looking for the factors of 10 that will add to be 11. So I know I have 1 times 10 is going to be 10, or 2 times 5 is going to be 7. I'm sorry. That is also going to be 10, but it's going to add to 7. So we have here, it looks like the terms that I want to use are going to be 1 and 10. So we're going to divide, or we're going to split, 11x up into 2 terms, and we're going to make it 1x and 10x. So we've uncombined our terms. So we can see here, we are going to go ahead and split our middle term up, and then we're going to factor by grouping. So we take the first 2 and we group them together, and then we factor out the greatest common factor, which happens to be x, leaving behind 5x plus 1. And if you factored by grouping properly, the parentheses are going to be the same. So then we, in order to take 10x and get 5x, we would have factored out a 2. And then we regroup our parentheses, and we end up with x plus 2 times 5x plus 1, and we've now factored this. And to just show what I mean when I say we ungroup that, if we were to multiply this out, right? If we do our first, we get 5x squared. We do our outer, we do our inner, and then we do our last. And as you see here, what we've done is we've found that 1x plus 10x is 11x. So again, we were getting to those 4 terms prior to combining like terms. But let's go ahead and practice this a few times and These first ones are pretty easy, and they're easier than later on because we are dealing with actually some prime values here. But we are looking for the factors of A and C, which sum to B. So 6 times 5 is 30, so my factors of 30 would be 1 times 30, 2 times 15, 3 times 10, 5 times 6. And then we see our summations over here to the right. So we were looking for 13, so we know that we are going to separate 13x into 3x and 10x. So when I go to rewrite this, I have 6x squared plus 3x plus 10x plus 5. Now, it doesn't matter which order that you put the 3x or the 10x in, you're going to get the same answer in the end. It may look a little bit different as you work it, but it'll be the same. So we're now going to group. Now that we split 3 into 4 terms, we're going to group our first 2 terms and our second 2 terms, and then we're going to find the greatest common factor of each. So the greatest common factor of 6x squared and 3x should be 3x. And when I factor 3x out of 6x squared, that leaves behind 2x. And then 3x factored out of 3x is going to leave behind just 1. And again, the hint, if you factored by grouping properly, the second parentheses will be the same as the first. And in order to figure out what I've factored, since factoring is reversing the multiplication process or division, if I take and I divide 5 by 1, I get 5. So that is what I'm factoring out. And you can check this. If I factor 5 out of 10x, I get 2x. Or if I were to multiply 5 times 2x, I get 10x. 5 times 1, I get 5. So I'm able to check those. Now I'm going to go ahead and regroup them. And I know that one of my parentheses has already been established. It's 2x plus 1. And then the other parentheses is going to be what's left behind, 3x plus 5. And there you have it. We've done factoring by grouping. This is a very challenging skill. Once you get the hang of it, it will be very easy, but it will take a little bit of practice. And this is going to be the most important skill that you can walk away from algebra with. Personal opinion, but you're going to be able to use factoring a lot in future math to make problems easier. You factor a polynomial and you can simplify it. Don't have to solve for it. So moving on, you can see here at number 2, factoring when AC is negative. Well, we're doing the same thing. We're going to multiply A times C. So we have A times C is giving me negative 45. Now, since our value is negative, we know that one of our factors has got to be negative. And if you look here, if one of our factors has to be negative, but the center value when we combine it is positive, that means the positive factor is the larger factor. So you can practice this, of course, but let's just think what is negative 1 times 45? That's negative 45, and it will add to be 44. We have negative 5 times 9, which will be negative 45, and it will add to be 4. And there you go. We can actually stop right there because we found out what we were looking for, right? And then when I split my terms up, so I split 4 into, I split the trinomial into 4 terms, and I rewrote 4x as negative 5x plus 9x. Or as I wrote over here, again, it doesn't matter which order you put it in, but I have 3x squared plus 9x minus 5x minus 15. That's an equivalent trinomial. So I've gone and I've grouped the first 2 terms and the second 2 terms, and the greatest common factor here in the first 2 terms are going to be 3x, leaving behind x plus 3. And then again, the second parentheses is x plus 3, and when I factor out an x from negative 5x, I get negative 5, so that's what I'm going to be factoring out there. So when I rewrite my parentheses, I have 3x minus 5 times x minus 3. Okay, so let's go ahead and do this next one. first thing we want to do is we want to take and multiply a times c and start with our factors. And hopefully you recognize that when we multiply a times c, we want those factors to add up to be a positive 31. Okay, so as we go ahead and we multiply a times c, we get negative 140. And we know that we want the factors of negative 140 to equal 31. Well, I've gone and I've thrown in a couple of factors there. Negative 2 times 70, negative 4 times 35, and negative 5 times 38. And I was able to find that, well, negative 4 times 35 is going to be 140, and the factors are also going to add to a positive 31. So I want to be able to then take and separate 31x into negative 4 and a positive 35. So I have 10x squared minus 5x, sorry, I just said 1 and wrote the other one, minus 4x plus 35x minus 14. Okay, so again, we're going to group the first two terms, we're going to group the second two terms, and we're going to find the greatest common factor of our first two terms. And hopefully you can see that the greatest common factor of 10x squared minus 4x is going to be 2x. If I factor a 2x out of each of those terms, I end up 10x squared divided by 2x is going to be a 5x, and then negative 4x factoring out that 2x is going to give me a negative 2. Again, if we did it right, what's in the parentheses is going to be the same. So simply take negative 14 divided by negative 2, that's a 7. There you go. So 7 is going to be what I'm factoring out there. So when I rewrite my two parentheses, I have 2x plus 7 and then 5x minus 2. And that is factoring by grouping. Let's see here. Here's our wonderful word problem, right? I've gone and given you some of the information. The area of the rectangle is 8x squared plus 22x plus 15. And then what are the possible dimensions of the rectangle? Well, we're talking about area, so I know the area is length times width. So what I can do is I can factor that polynomial into two factors, length and a width. And that's what they're going to represent. So let's see if I can factor it, and hopefully I get two terms out of it. And in factoring, we know that, again, we want to multiply a times c. So 8 times 15 is going to give me, 120. And then the factors of 120 that are going to equal 22. So that would be, anybody want to just say 10 times 12 is 120, and it also equals 22 when I add it together. Okay, so I want to separate 22x into 10x and 12x. So I have 8x squared plus 10x plus 12x plus 15. Again, I've just rewritten the expression, and then I'm going to factor the first two terms and the second two terms. And I know that these two terms right here, their least common factor is going to be 2x. And the least common factor here is going to be between 12x and 15 is going to be a positive 3. And I'm just going to see now if it's going to work out. 8x squared, when I factor out 2x, is going to leave behind a 4x. And then 10x factoring out a 2x is going to leave behind a 5. And then if I were to factor 3 out of 12x, that leaves behind 4x. And then if I factor a 3 out of 15, that leaves behind a 5. And sure enough, it worked. There you go. And there's my factor in the number. Okay, so then one of these is going to be my length, and one of them is going to be my width, and I don't know which one is which at this point in time. All right, so we're doing the same thing here, but what we may notice in the beginning, factoring out a monomial first. When we just look at our expression, and I've already done this, you always want to check for a greatest common factor first. Why that allows you to decrease some values. If I look at this and I say, okay, I'm going to factor that, well, I'm going to factor AC method, right? By grouping, I'm going to have to multiply 18 times 32. That's going to be a much larger number unless I happen to notice that, well, I can factor out each one of these terms. I can factor, they have something in common, and it is a 3. So the greatest common factor of all these terms happens to be 3. So I'm going to pull that out of my trinomial. And now I can factor this just with the values of 6 and 4, which decreases the factor tree that I'm going to have to come up with because it's much smaller. And I know when I multiply A times C, I get 24, and I still want it to sum to be B, which is negative 11. I've created my factor tree. I have negative 1 times a negative 24. And did I mention that I'm using two negative factors here with a positive number? Well, if my C value is positive, but my B value is negative, that means both of my factors must have been negative, because a negative times a negative will provide me that positive number. So there you go. So what we're going to do here then, on a side note, is we're going to take and we're going to separate. We're going to go ahead and separate negative 11x into negative 3 and negative 8. So I have 6x squared minus 11x, minus 8x minus 3x plus 4. And I've gone and I've separated the factored out the greatest common factor of both terms, rewritten it as in 3 times 2x minus 1 times 3x minus 4. And there is my factored trinomial. I just happened to notice ahead of time that I had a 3 that I could factor out. If we got to the end and you hadn't factored that 3 out, you'd want to make sure that you factored it out now, because we are still looking for prime factors. Okay, so looking here at this next example, if we're going to factor B, right? I have 8, I have a 36, and I have a 20, and they all have something in common that I can factor out, and I believe it's going to be a 4. They can all be factored out, factored by 4. So if I factor 4 out of each one of those terms, that leaves 2x squared minus 9x minus 5. And then now, and I've gone and changed it from parentheses to brackets, since that will be less confusion that way, right? Parentheses within a parentheses can be a little bit confusing, so I use brackets just to differentiate. So here, if I have my 2 terms in 4, my AC is going to be 2 times negative 5, which is negative 10, and I want them to sum up to be negative 9, which hopefully you guys are getting better at factoring. So these factors are going to be negative 10 and a positive 1. That's going to give me a negative 9. So I can go ahead and split this up to 2x squared minus x, plus x minus 10x minus 5. Okay, so there's my factoring by grouping. So I'm going to group the first 2 and the second 2, and I'm going to find the greatest common factor of each. So I have 4 times the greatest common factor of 2x squared and x is going to be x, leaving behind a 2x plus 1. And then, of course, if I factored by grouping properly, this is going to be the same. And then I look at negative 10x minus 5. In order to get 2x plus 1, I needed to factor out a minus 5. So my factor is going to be x minus 5 times 2x plus 1. Listen, it's going to take a little bit of time, and it takes a little bit of practice, but once you have it, it's there. We're going to do this for 2 weeks. Factoring, it's an extension of our multiplication. It's reversing that multiplication process. So if you understand the multiplication process, you should understand the factoring process. As one student, told me, I got it. Takes a little bit of practice. She took it home. She did her homework one time. She brought it back the next day. She was able to factor from then on out. But it will take a little bit of practice. So there you have it. Again, there's my final answer. And good luck with factoring again. We're always looking for a common factor first, and then we worry about factoring our trinomial. And if our trinomial, if the value of our a is greater than 1, we're probably going to have to factor by grouping. And then being able to make our factor tree, summing up, seeing those patterns. Let's get some practice.